こんにちは、皆さん。はじめまして。名前はベンです。
お元気ですか？私はブラッドです。
ごめんなさい。私たちは日本語を話しません。では、we will continue the rest of our presentation in English.
Welcome to Hashi Talks Japan. Today we'll be talking about taking your Terraform skills to the next level. So we will talk about, this is generally for people starting off, and we will give you some tips and tricks of how you can improve your skills and make your code better.
Right, my name is Ben. I work as a solutions engineer here in Australia.
And my name's Brad. I'm a HashiCorp ambassador and I organize the Sydney HashiCorp user group. I've been in DevOps for quite a long time now, probably around 6 or 7 years. I spend a lot of time in the open source community, working with the Continuous Delivery Foundation and the Cloud Native Computing Foundation, and also HashiCorp. So today we will talk a lot around functions. So how you can make your code better by leveraging functions. So whether it's string functions or many more that we'll see soon. We will also show you the for each or the count, what you can do with your modules. So for each will allow you to, if you have different environments like dev, production, you can choose to have either 0 or you can have multiple objects, and then you can pass those through your modules, therefore making your code smaller and reusable, which Ben will show you. And then we'll also talk a little bit about validation as well. So how we can validate what our development teams are putting in as the input, and a little bit of tips around that as well. So the first thing we would like to show you is most cloud providers will use tags. In cloud computing, tags are probably one of the most important things. They're used for security tools, for observability tools. A lot of automation that we do is around tags. So one really nice function that Ben and I, when we used to work together, we send the merge command. So you can see here at the top, we have common tags. So we define we make a template and we give this to the development teams. We define what is a compulsory tag that we want. So this could be something like environment, project, client ID. There could be many common tags that you would like. And then for each development team, they might want their own custom tags. So they might want, one example is the data team, or they might have a special automation script that they need to tag it with. So what you can do to consolidate the tags and to put them together is use the merge command. So you can see here that in the bold, we say tags equals merge, and we're passing through the common tags and the custom tags, and Terraform will then use that function to make the list the same. So it's quite a nice function that we found. You could also put another comma and add one key value pair if you liked as well. So that was something that we really found useful when getting introduced to functions. It made our code. You want to make your code as sort of small and reusable as possible. So this really helped us. Another thing is the format command. So for me personally, I like this because it looks like Golang and looks like the Go syntax. So you can do the $ with the curly braces and have the same effect, but I quite like the format command because it makes it look cleaner and easy to read. So you can hear we have the percentage sign and S for string, and then you can see the output is going to be the project and environment and that's one way that you can concatenate strings or integers, whatever it may be. We also have the replace command as well. So this could be really useful when you need to replace file names and things that you don't want, such as trailing backslashes. You might have another programming language that does something that you don't want, and you can take that out with the replace. So you can put in replace what you want to replace, and then I say I want to replace tuna with salmon, and then you will see that that gets replaced. So you could do a lot of things with like blank spaces, etc. So that's one thing that you could also do. And there's many commands. So here you'll see that if you go into the link here, we will have Terraform language functions. And this is one thing if you're considering going for your Terraform exam, which is it will really help you. It's a really nice exam to do. And you will go and study all of these as well. So there's many great things to learn. If you do take the time and study it, you'll find that you will write much better code and you'll do it faster. So it's well worth going over this link and checking out some more functions. So I'd like to hand you over to Ben now, and he will be talking over the forage and the account as well. Thank you.
Thank you, Brad. So yeah, as Brad mentioned, there are certain scenarios where you would use for each and other scenarios where you would use count. So what I would like to explain is the differences between these two and when you would choose to use one over another. Now here are some similarities for count and for each. In count, it's very useful when you use it for a Boolean condition. So in this particular example, if you're trying to build a highly available multi-region type setup, you would need a primary resource and a secondary resource. With this multi-region count way of writing the code, if you see at the bottom portion, count equals multi-region 1 or 0. So if multi-region is false, that just means that it will not create the secondary resource group. This is a very similar thing that can be done with for each. So in this case, what I'm doing is creating an Azure resource group called HashiCorp. And if it's multi-region, you will get the first argument, which is primary and secondary. Whereas if multi-region was false, you get the second portion, which is just the primary. And the way you select what to pass in, the name, each dot value, so that just passes in the word primary into the resource group. So in one resource block itself, you can make it work to create one resource group or two resource groups. Whereas with the count, you're seeing two separate resources. So that's one way you can use for each to even simplify your code a little. Now, the difference between count and for each when you're doing this kind of setup, when you look at this, if you're trying to access the name of the primary resource group, Azure RM resource group .primary.name, that works. But this does not work for secondary, because when you use a count, it comes out in the form of a list or an array. So you will need to have the square bracket notation with 0 in order to actually get the secondary word. So that, to me, feels a little inconsistent, and it's a quite high risk of error when you write your code, because primary.name against secondary 0.name. Now, if you were to do this with a for each, on the other hand, it's actually consistent. It's labeled as a key value pair. So what it then does is it looks at Azure RM resource group .HashiCorp and .primary or .secondary. It's the same way you would refer to things, which makes it, to me, it's more consistent, it's more natural, and because it's consistent, it's less likely for you to have any mistakes when you're writing the code. Now, there are even more benefits to using for each, and not just for each, it's the way you would pass variables in when you're trying to create multiple things. Like in this particular example, where I'm trying to create multiple AWS S3 buckets. Starting from the top, it's just declaring a variable of S3 buckets. And the next portion there, S3 buckets, this is the value that I'm passing into the resource when I'm trying to create it. So I'll have application A, production, application A, test, application B, B test. Now, all I need to do when I create a resource is write for each S3 bucket, and you'll be able to see that you can use each.key, which would refer to the key portion, which is the left column, application A test, B, or B test. Whereas when I'm trying to pass the further information in, you'll see in the tags that environment equals each.value.environment. Each.value just gives you, it's just like any other object, right? Each.value just gives you the right-hand side of the argument. So value.environment, that will give you production or test, or production or test. Now, after you've created this resource, you are still using the exact same way of referring to something by the key, which you can see AWS. You see it in the blue portion on the right side of the screen, AWS underscore S3 buckets dot HashiCorp, because that's the name that we gave it, dot application A or application B or A test or B test. You just use the key. Whereas if you were to try to create a number of resources using count, you would need to use the square bracket index, which how would you know whether it's index 0 or index 1 or index 3? Because there's no link. I don't know if index 1 is supposed to be application A test or application B. So using an object like this, it makes it much more consistent, and it's also easy to scale. So I can add application C, and it will just build the fifth S3 bucket with no issues at all. So that's what I really like using for this particular purpose, to create as many things as I want. And all I need to do is just add on to the list of variables, add on more key value pairs inside the object that I'm passing in. Now, it's quite important that when you do stuff like what I had just shown here with application A environment production, you need to make sure that the developer isn't passing in things that you are not approving of. Like in some companies, they use the word prod, P-R-O-D, rather than production. So this itself can create a bit of inconsistency, as one developer may use the word prod and another developer may use production. And all of a sudden you've got drift. Which word am I supposed to use? That is where you start using this validation thing, this function that Terraform gives you to ensure that variables are what you want it to be. So what is validation? This is a way where you check that the input variables that were passed into the tf-vars file is acceptable from an internal standards check. Internal standards meaning what your company, your developer team wants to do before this request gets sent to the API. Now, it's important to know that this is an internal check. It does not get validated by the cloud provider itself. So even though you use the word production, it doesn't mean that AWS, GCP, or Azure will approve of it, but it's more for an internal consistent method. Now, how do you use it? So firstly, to use it, what you do is write the validation block. As you can see in the bottom of the code, that green portion, validation, all you do is write it in within a variable itself, and it takes in two things. Firstly, a condition, which will give you a true or a false. Now, if it's true, that will proceed without any issues. If the condition ends up being false, you will get the error message that has been chosen. Like in this particular example that I'm showing you, we are creating a variable called AWS region. And as a company standard, we only want to deploy in Japanese AWS data centers, which is AP Northeast 1 in Tokyo or AP Northeast 3. So what I do in the validation bit here is I set the condition that whatever you pass in AWS region must be one of these two values that I've provided in the list. So if you were to pass in, say, a European endpoint, AP Europe-1, you will get an error saying acceptable values for AWS regions are AP Northeast 1 or AP Northeast 3. Now, this is an internal error, so it is completely up to you and your dev team to make it as clear as possible to understand what you're expected to write in there. So if a developer, comes in, writes AP Europe, before it even gets sent out to AWS, the Terraform CLI itself would give you an error saying, no, you've given me something that has not been approved, and therefore it will stop the Terraform apply or even the Terraform plan. Now here's other examples. Validation can be done in many different ways, right? I was just describing that. This is an example of how to validate certain things. Like say if your company has a standard where you must have a project ID, and the project ID is a specific format, 6 characters long. So again, this condition, it must end up in a Boolean value. So length is one of the functions that Brad had shown earlier in his functions page. You can use length to make sure that the string that gets passed in here must be 6 characters long. So if someone passed in something that's shorter, longer, it will just give you an error. Project ID must be 6 characters long. So that's the same thing that is done for the second example that I showed below, variable environment. What I was talking about before, some companies use prod, P-R-O-D, other companies use production. And if you try to pass in production, you will get the error that you see on the right in red, invalid value for variable. Someone has passed in variable, var environment is production, and the error that you get just tells you environment must be one of the following, dev test prod, which is the exact error message that we had written in the error message of the validation. So this can be expanded in many ways. It is just done the way that your company internal standards want code to be written. So it's just purely input validation. Say you can also check for if I'm expecting a number. For example, if you're doing a virtual machine and you're asking how many cores it's expecting. Now, Terraform doesn't know to automatically convert numbers to strings or strings to numbers, but this is something that you can also confirm to use validation. I'm expecting a string. You've given me a number. I don't like it. Here's the error message. So this is one of many ways that Brad and I have used validation before, and it has saved us quite often, when to prevent developers from accidentally deploying resources that do not match the naming conventions, that in some ways even it control the billing aspect very well, because some developers may be more focused on, say, working on the front end or the back end. They don't know as much about the cloud hosting side. So they would just deploy a service with a more expensive tier than what is actually required. And therefore, we can have these validations here that says, no, you cannot deploy to a premium tier or an expensive tier. You can only do these tiers that has been approved by the budget. So these are more examples that's how validation can help you in just setting up guardrails to ensure that your project runs the way it should. Now, what's important to note, when is validation done? So even when you write all these conditions and error messages, when you run Terraform init, it doesn't check your variables. Terraform format doesn't check your variables either. Terraform format simply just makes your code look consistent. The strange thing is Terraform validate does not run the validation. It's only on Terraform plan and Terraform apply where Terraform actually looks at your tf-vars files, puts the values in, and checks each variable. Did it meet the condition? Did it pass? If not, put the error message. And when there are no error messages, that's when it actually runs the plan and apply. And with this, I'm handing it back over to Brad to wrap up and have any closing words.
Yeah, thanks, Ben. I guess a few questions for you. So when you were learning Terraform, we talked a little bit about the certification. How did you find doing the certification?
Well, the Terraform Associate Certification, it was actually a very useful course because a lot of times what we do is we learn Terraform by doing. And we learn it by quite often just mimicking what other people have taught us. Now, they may or may not be teaching best practices, for example, like, I was talking before about the difference between using count against using for each. Just because something works in a certain scenario doesn't mean that that should be the way it's all being done. All should be done. And that's why when I did the Terraform Associate certification, it involves reading through the Terraform docs and understanding what is the best practice of writing Terraform. And that way you have a consistent way of doing things that is HashiCorp approved, pretty much, which to me, it makes things more consistent when you do it a certain way. It's sort of like, following industry standards, and just whether one dev does it, if every developer follows the Terraform way and the HashiCorp way, it would be a lot easier for you to look at someone else's code and understand exactly what was being written.
Yeah, I agree. I think I was doing Terraform for maybe 1 or 2 years before I did the certification. And I realized that if I actually did it at the start, I would have accelerated my work a lot faster, and I wouldn't have, had to go back and write the code again in a better way. And I just really felt that I don't like all types of exams, but this one in particular was quite good, and it did really advance us, didn't it? Doing the course. So if there's a key takeaway of this talk, I would say that if you do want to increase your skills, I think the certification is a great way to go back and learn the things that you don't necessarily learn on your day-to-day job. And it sort of makes you think outside the box a little bit more of what you can do as well. So yeah, I would like to thank everyone for listening. And any closing remarks from you, Ben?
No, when I first started doing Terraform, it took me a little bit of getting used to just to understand the syntax. But after understanding how Terraform works, it's why would you do things any different? I can never going back to like going into a portal and point and click and deploy things again and again, because that, firstly, it's slow. And the chances are every time you deploy something, you might click something different and you get a different result. So infrastructure as code is definitely the way you should be doing things. And Terraform just makes it so much easier. What about you, Brad? Did you like it?
I think, I like it. And I think for folks starting out learning, that there's a lot of HashiCorp user groups. So generally there's a HashiCorp user group in each city. You can go to meetup.com and you can find that group as well. You don't necessarily have to live in that city to attend. A lot of them are online at the moment. So we have one in Sydney, for example. Everybody's welcome to join. We do at least monthly meetups, and we talk about best practices, and other people share their learnings as well. So everybody's more than welcome to come to the Sydney user group that you can find on Meetup or Google. So yeah, thank you very much. And sorry we couldn't speak any more Japanese, but we tried our best.
Well, at least we ended in Japanese. Arigatou gozaimasu.
Arigatou gozaimasu.
See ya.
Bye.